All right, so quiz 4, give the mechanism and the product for the reaction below. And then my hint is just use H minus for step 1, right? So the only time lithium aluminum hydride or sodium borohydride, the only time you need to you can't just use H minus is when it's lithium aluminum hydride reacting with the carboxylic acid. That's the one time where you have to like draw it out. Otherwise, you can just pretend it's H minus. So lithium aluminum hydride with carboxylic acid. We did that in a workshop. But for all these, you can just pretend it's H minus. So you just keep redrawing H minus. Similar to before, right? You have an aldehyde, and this is a carbonate. Not a carbamate, but it's a carbonate. So it's like a double ester is a carbonate. But the first thing you're going to react with is the aldehyde. That should be the first thing because that's on top of mountain carbonyl. Little thing. You add in, make a tetrahedral intermediate. There's no good leaving groups, so you're up. But wait, there's more carbonyl, so I'm going to keep adding H minus, tetrahedral intermediate, kick out one side of this carbonate. All right? Doesn't matter which side you picked. Keep adding H minus. All right? Tetrahedral intermediate, still got a good leaving group. Okay. Do another elimination. All right? Keep adding H minus. Still got a good leaving group. Nope, no more good leaving groups. Now you got this O minus, and you also have this other 3 O minuses piece up here, and you just protonate them all in the last step, the second step, and those are your products. So I try to give you a hint by showing this methanol, right? That methanol, this carbon right here is actually this carbon, and that's where that ends up. And all these other pieces, right? 1, 2, 3, 4. 1, 2, 3, 4. And then this is the other carbon that's from methanol. So again, the key is keep adding stuff until there's no more carbonyls left, right? Or there's something it can't react with. Lithium aluminum hydride, remember, is super reactive. If it was sodium borohydride, that'd be a completely different story here, right? Sodium borohydride, you'd only react with the aldehyde. That'd be it. Nothing else would work. That's all it would react with. So number 2, draw 3 different resonance structures for the radical below. So you've done a lot of resonance structures. Hopefully that isn't too hard at this point. It's just the difference here is when we're moving one electron at a time, there's those single-headed arrows, like they call them fishhook arrows. So you, instead of having, right, you're kind of moving them together. And the big thing I want to emphasize to folks is you bring the electrons to the bond. If you're making a new pi bond here, you got to show those electrons going to that bond kind of together to form that pi bond. The other one goes to the atom, and then just kind of moving them around. I went to outside the ring. You could have gone inside the ring. It doesn't matter. I just showed 3 possible examples, but hopefully this wasn't too off for most folks, the idea of practicing this. So number 3, I kind of thought I knew it was going to be maybe a challenging one. I wanted you to kind of work backwards from here. So we talked about this a little bit. So this was give the starting material and mechanism for the reaction below. I wasn't necessarily looking for the mechanism here. I was just looking for the stuff here. If you did the mechanism here, it's fine. If you didn't get it wrong, then I won't grade it wrong. But make sure you should know how to do this, right? I could show, right, how this is actually made, of course. Right, the magnesium kind of jumps in there. So what I wanted you to be able to recognize was, okay, here's this Grignard reagent. What did it come from? And there's the magnesium starting material. So hopefully you recognize that the magnesium must have jumped in between this carbon and bromine, and that this was the starting material. Right, this was the starting alkyl halide piece. So once you make the Grignard, now you're having your Grignard react with epoxide. Epoxides, right? Remember, we can react in acidic or basic conditions. So you got to identify this in Grignard, that's basic. You have a carbon with a minus charge, right? So always look at that first step for whether it's acidic or basic. So if you see a negative charge, it's basic. So we go to the less substituted carbon of the epoxide, right? That's at regioselectivity. Less substituted carbon, like an E2. Bromine adds there. And then another little kind of fun twist, right? Instead of just protonating this, I added another electrophile in there and said, oh, do another SN2. Now this oxygen could do an SN2 there and kick out the bromine, and that's how those 2 carbons get added there.